Don Markholtz, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 36 for the week of September 9th, 2020. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com, 2 H's. What's up in the sky this week? As our week begins on Wednesday, September 9th, the moon is 60% full in the morning sky, and it will be at last quarter on September 10th. The moon passes just north of Venus on September 14th. After sunrise on the 14th, you might want to use the moon's position to find Venus in the daytime sky. This past full moon, September 2nd, did you look closely at the moon on that night or on the 2 nights before or after? I suggested an experiment in podcast 24, looking at the moon and seeing if you can discern some shadiness on the north side of the moon, since the moon was about 5 degrees south of the ecliptic. I looked at it and noticed the north edge of the moon showing some contrast among the craters, something not visible on the south limb. We'll try that again next month on the October 1st full moon. That was fun. September is my favorite month for astronomy. In the evening sky in the northern hemisphere, it gets dark sooner. So by 8 p.m., you're out looking at stars, no more waiting until 9:30. The summer Milky Way runs through the meridian, and the nights are still warm and not too hot. In the morning sky, twilight is a minute or two later each morning, revealing more sky than normal. And when comet hunting the winter Milky Way low in the east, I see lots and lots of stars. An illusion that I'm seeing very deep and picking up faint objects. Will you be able to see the International Space Station this week, which for our purposes begins on Wednesday, September 9th and runs through Tuesday, September 15th? It depends on where you live. This week we have 4 zones. If you live north of 45 degrees north, the ISS will be visible for the first part of the week and for most of the week in the morning sky. Iceland, England, get up early. From 25 to 45 degrees north, it will be in your morning sky for the whole week. And towards the end of the week, you'll see some evening passes too. Korea, that is you. Italy and Portugal, you too. From the equator to about 25 degrees north, it is in both your morning and evening sky for the second half of the week. Vietnam, Mexico, I'm talking to you. South of the equator, the ISS will be visible in your evening sky for only the first part of the week, and then it disappears. Everyone south of Ecuador, that is you. To determine where it will be in your sky, go to the website heavens-above.com, enter your location, then click on ISS. You can also click on some of the other satellites and observe them too. A couple of weeks ago, I was interviewed by Neil Norman and Nick Evans from Comet Watch, a YouTube podcast from England about comets. Those guys really do know their comets. The interview lasted nearly 2 hours, and a link to that interview is on my website. We are doing a series on my 1985 book, A Decade of Comets. This 110-page study of the 33 comets visually discovered by amateur astronomers from 1975 through 1984 can be downloaded free from my website, Markholtz.com. Last week was part 1. This week it's part 2A. Part 2 of this book is so long I broke it into 3 sections. So you can download it from my website. It is Podcast 36, A Decade of Comets, Part 2A. Part 2 is the longest part of the book, and when I wrote this book in early 1985, I used a Commodore 64, and I saved everything not on a disk drive, but on a cassette tape. And one portion of this section, I recall spending several hours writing, and then I thought I had saved it on the tape. The next time I wanted to bring it up, it was nowhere to be found, and I had to rewrite that portion. Comet discovery stories can be exciting, and I think this is what a successful visual comet discoverer meant when he told me that reading this book inspired him. And Part 2 outlines the discovery of each of the 33 comets. This week, we cover the first 12 comets. For each comet discovery, I begin with a table of facts. Read through it carefully. It gives tons of information about each discovery. Most of it is self-explanatory, but the previous 4 pages, which are also repeated with Part 2B and Part 2C in future weeks, will explain each and every bit of data here. So let us begin. Just 4 days into our decade, the first comet was discovered. The German Reverend Leo Bothian, a missionary serving in the Philippines, discovered this 11th magnitude object in the evening sky. He was using an 8-inch reflector, that's 20 centimeters, and had been searching for about 100 total hours for at least the previous 6 years. It turned out to be a periodic comet, returning every 11.05 years. This is Bothian's first and only confirmed comet. Twice before he had found a comet, but he was unable to notify the Central Bureau for Astronomical Telegrams in time for them to be confirmed, and both comets faded from view. When Comet Bothian returned in 1986, it was designated or redesignated Comet 85P, meaning the 85th comet to be recovered. And it did well in 1986. It was not seen in 1997 due to bad placement in our sky. And prior to 2008, it was chosen for a visit by the Deep Impact spacecraft, which had originally visited Comet Tempel 1. However, by late 2008, the comet had not yet been recovered, so the Deep Impact spacecraft was rerouted to periodic comet Hartley 3. Periodic comet Bothian is now believed to be lost. Perhaps it disintegrated. Some comets do that. In my book, A Decade of Comets, for each comet, I rerun the orbit, changing the ascending node by 90 degrees, keeping the other orbital elements the same. Then, for each of the 4 orbits, the original one and the 3 imaginary orbits, the probability of discovery is estimated by me, and the average discovery probability is in the table at the heading of each comet discovery, in this case 40%. Our second comet was found by the most prolific visual comet discoverer in the 20th century, William Bradfield of Australia. Get used to his name. He discovered 10 of the 33 comets covered in this book. A rocket scientist with the Australian government, born in New Zealand but living in Australia, Bradfield was a real smart guy who studied comet discovery and was innovative in his searches. William Bradfield visually discovered 18 comets between 1972 and 2004. He passed away in 2014. All of William Bradfield's finds were by him alone. No shared discoveries here. Also, all of his comets were found south of the equator. He did not have much competition in the southern hemisphere, and he knew that. He once wrote me that as the moon clears the skies, he first searches the more competitive northern hemisphere, then the southern hemisphere. The humble and hard-working William Bradfield. This comet was discovered March 12, 1975, in the evening sky at magnitude 9.3. Bradfield was using his 6-inch, that's 15 centimeter, refractor telescope with a 2.2 degree field of view at 26 power. And he used this for most of his discoveries. Now, this find came 145 search hours since his previous find 13 months before. So he averaged during that time about 11 hours of searching per month. Our third comet was an accidental find by 2 of the 3 observers. It is known as Comet Kobayashi-Berger-Milan. It was discovered 133 degrees from the sun in the morning sky, but it was above the horizon for most of the night. Most of the accidental comet discoveries, that's comets found by someone not looking for comets, are typically found far from the sun, where most comet hunters are not searching. Toru Kobayashi, and this Kobayashi is not the same guy who was the hot dog eating champion. Toru Kobayashi found this comet on July 2nd. As a comet hunter, he had searched 117 hours, and he found it with a 6-inch, a 15 centimeter reflector at 30 power. The comet was fairly bright at discovery, magnitude 7.6. Kobayashi got the position, but not the direction of motion, and his message was delayed, reaching the Central Bureau for Astronomical Telegrams, the Comet Clearinghouse, on July 4th. Also on July 4th, at a star party at Henry Cole State Park near San Jose, California, Doug Berger was looking at the globular cluster M2. This is one of the Messier catalog objects. Next to it, he found a fuzzy patch of light. He was using a homemade 8-inch reflector. It was our late friend, Jerry Ratley, who convinced him that this was a comet and that he should report it. 20 years later, Jerry Ratley called me 2 days after Comet Hale-Bopp was discovered and asked if there were any comets near M70. He missed it by about a day. But back to Comet Kobayashi-Berger-Milan. Dennis Milan, who wrote for Sky and Telescope magazine, found the comet from Yellowstone Park in the Mount Washburn parking lot using a 4-inch reflector. He too was looking at M2, and he found the comet. Dr. Brian Marsden later told me there were as many as 50 independent discoveries of this comet, including one the day before Berger's find, and at least 3 before Milan's find. But the comet was not properly reported, and those discoverers did not get credit. This happens sometimes with accidental finds. The comet continued to brighten and became a naked eye object. Meanwhile, Doug Berger and I became good friends and co-workers several months after he found this comet. Doug is alive and well and lives in Oregon. The comet could have been found earlier if it had behaved properly before discovery. 3 weeks before, it was magnitude 10 and sitting in the morning moonless sky. It was far from the sun and not where the comet hunters were typically sweeping. When it got close to a bright star cluster, many people found it. Our next two comets were found on the same morning within a few hours of each other, on October 5th, 1975. The first one is the fourth comet in this book, Comet Morai, Sato, Fujikawa, all of Japan. This was Morai's first named discovery. He was using 20 by 120 binoculars and had searched for 250 hours to find this comet. Sato, using a 6-inch, 15-centimeter reflector at 25 power, had searched for 203 hours since his previous named discovery, and this was his third. This was also the third comet discovery for Fujikawa, who was using a 6.2-inch, that's a 16-centimeter reflector at 23 power. He had searched for 560 hours since his previous find. This comet was rather faint, magnitude 10.7 at discovery, and 65 degrees from the sun in the morning sky near the equator. It was found about 20 degrees north of the path that the sun-grazer comets take on their incoming path. By the end of the year, this comet brightened to magnitude 8.5. It did not get close to the sun with a distant perihelion distance of 1.6 astronomical units. Our fifth comet was also found on October 5th. It is Comet Suzuki, Saigusa, Morai. Suzuki used a 5.8-inch, 14-centimeter reflector and had searched 460 hours to find this, his second named comet. Saigusa used a 6-inch, 15-centimeter reflector and had searched for 480 hours to find this, his first named discovery. And Morai? He had discovered his first comet only 70 minutes before. This comet was 8.8 magnitude at discovery and in the northeastern morning sky, 52 degrees from the sun. It was a fairly easy and obvious comet to find. The moon was at new phase on the date of these two comet discoveries. I once asked Dr. Marsden about the Japanese comet hunters and how come so many of their finds are found by several comet hunters on the same morning as occurred here. We already knew that in Japan there was a group dedicated to comet hunting, and it had nearly 100 members. Dr. Marsden stated that in Japan, a relatively small country, when the sky is cloudy, no one comet hunts, but as soon as it clears, and generally it clears for the whole country, everyone goes out comet hunting. This was also the day of new moon, and I have noted that many of the Japanese comet finds are made on the morning of the new moon. William Bradfield found our sixth comet of 1975 on November 11th. It was found in the morning sky, 58 degrees from the sun at magnitude 9.7. Bradfield was using his 6-inch refractor and had searched for 106 hours since his last find 8 months before. This comet was found near the incoming path for the Kurtz sun-grazing comets, an area that many comet hunters sweep. The comet eventually went close to the sun, 0.22 astronomical units. Our last comet of 1975 and the seventh comet discovery that year, more than double the 3.3 finds per year, was found by Sato, who had found his third named comet only 2 months before. This was 16 search hours with his 6-inch reflector. The discovery date was December 5th, 1975. The comet was 78 degrees from the sun in the morning sky near M85. It was magnitude 9.8. It was later reported on IAU Circular 2906 that Usanomiya of Japan observed the comet on November 30th, some 5 days before discovery. For some reason, however, it was not reported to the Smithsonian, so he did not get credit. He would later go on to visually discover 3 comets in 1997, 2000, and 2002, more than 20 years later. So that was the year, 1975, 7 visual comet discoveries. I had searched 307 hours and had not found any, but in these stories, I do report on those I missed for some reason or another. The year 1976 saw only 2 visual discoveries. We go from 7 to 2. William Bradfield found both. On February 19, 1976, he found his 5th comet, 57 search hours after his previous find 3 months earlier. At discovery, the comet was in the evening sky, 56 degrees from the sun and magnitude 9.4. Then, on March 3, 1976, William Bradfield found his 6th comet. This was only 12 days and 9 search hours since his previous find. What else was happening in the sky this week? Comet West was putting on a fine display in the morning sky. This comet was magnitude 8.8 and only 40 degrees from the sun. It could have been found only from the southern hemisphere. It was moving fast, 3.2 degrees per day. Typically, comets move about a degree per day when found in the morning sky, and much slower in the evening sky. It would be 18 months before the next visual comet discovery. This is the longest time span between visual comet discoveries during this decade. The 10th comet discovery we will examine was found by Merlin Kohler of Quincy, California on September 4, 1977. This was the first comet to be intentionally discovered by an American amateur astronomer in 9 years. The late Merlin Kohler was using an 8-inch, 20-centimeter Schmidt-Cassegrain telescope, a Dynamax 8. This find took him 100 hours over 3 years. The comet was found in the evening sky, 68 degrees from the sun, near the bright stars of the constellation Corona Borealis. It was magnitude 9.5, a fairly easy object. William Bradfield swept within 2 degrees of this on September 3rd. I had swept over it and did not see it on August 17th when it was fainter. And it was later reported that the variable star observer Michael Verdenant found it on September 2nd, but did not report it. The comet could have been found a month earlier if it had behaved normally, so it is possible that it brightened significantly before discovery. Our 11th comet was found by William Bradfield on February 4, 1978, 360 search hours since he found his previous comet 23 months before. He was averaging at that time about 15 hours of searching per month. Again, he used his 6-inch, that's 15-centimeter, refractor. This comet was found in the morning sky, 48 degrees from the sun, deep in the southern hemisphere. It was magnitude 8.0 at discovery. David Sargent, sweeping from New South Wales in Australia, swept to within 3 degrees of the comet the morning after Bradfield found it. He was hindered by a line of low clouds. David Sargent would later find his first comet 8 months later. This comet could have been found earlier by perhaps 6 weeks, but it was not. Perhaps it brightened shortly before discovery, or perhaps no one was sweeping the area. Meanwhile, 6 weeks after discovery, it passed rather close to the Sun, 0.44 astronomical units. The last comet we will discuss this week was a special comet, intrinsically the brightest comet of the 33 that I examined in this book. And with this find, we see the use of a large telescope to find a comet. It was the first comet discovered from Canada, and the first found by a Canadian. It was discovered on April 27th, 1978 by Rolf Meyer of Ottawa, Canada. He had conducted some searches in 1972 through 1974, but Rolf Meyer began systematic searches in 1975. It took him 50 hours to find this comet, and he would later find 3 more, all in very few hours and all in the evening sky. The late Rolf Meyer was using the Indian River Observatory's 16-inch, 0.4 meter reflector telescope at 56 power with a 1.25 degree field. The telescope is equatorially mounted, and he swept in a constant declination. Now, when I swept the sky with my equatorial mount, I live a little bit further south from Rolf Meyer. I sweep in a constant right ascension. So he swept in the opposite direction, in part perhaps because he was so far north. The comet was at magnitude 10.4 and 71 degrees from the Sun in the evening northwestern sky. At discovery, the comet was more than 3 astronomical units from the Sun. This is the second most distant of the 33 comet discoveries that we are examining in this book. It was visually observed in amateurs' telescopes for 18 months. This concludes Part 2A of A Decade of Comets. Again, you can download it for free from my website, MACHHOLZ.com. The file is called Podcast 36, A Decade of Comets, Part 2A. Next week, we will discuss more comet discovery stories in Part 2B. As for the comets in our skies this week, the positions in right ascension and declination for 5 comets are available on Podcast 35, Comet Positions. The 3 brightest comets are plotted on this map, Podcast 36, Map 1. They are Comet 2017 T2 Pan-STARRS. It's still magnitude 11 and it's slowly dimming. Comet 2020 F3 Neowise, which put on a great show in July, is now magnitude 10 and dimming more rapidly. And Comet 88P Howell, magnitude 9.5, and slowly brightening. Next week, we'll be adding a new comet in the morning southern sky. It's about magnitude 10. We'll not do it this week because the moon is still in the morning sky, but we will add it next week. By the end of the month, I'll be removing comets Pan-STARRS and Neowise off the maps as they're getting rather dim for our purposes. This week, we're going to look for the planet Neptune, the most distant major planet. It reaches opposition this week, meaning we are closest to it, but not by much. It rises as the sun sets and sets as the sun rises and is high in the sky near midnight. It's good to get out and see things at least once a year. You can't go wrong with seeing all the Messier objects each year, a few at a time, and each of the planets each year, and the moon more often than that, and watch at least one meteor shower each year. As you get more involved in astronomy, you'll find yourself going far beyond these suggestions of observing comets or minor planets or faint galaxies, clusters, and nebula, and perhaps variable stars. There's so much out there to see. But at least once per year, take a few minutes to see the planets and major deep sky objects. Neptune is 5 times larger than Earth and takes 165 years to go around the Sun. It is 30 times farther from the Sun than we are, so the light you see from Neptune left Neptune about 2 hours and 20 minutes before you see it. Neptune shines at 7.8 magnitude and is 2.4 arcseconds in size. It appears blue in color. Podcast 36, Maps 1 and 2, show the planet Neptune. Map 2 is a close-up which should help you find it. Try seeing it in binoculars. It will be faint but visible. You might or might not notice the blue color. In a telescope, Neptune should show a disk, blue in color. The largest moon, Triton, takes 5.9 days to go around the planet, and it goes around Neptune in a reverse or retrograde orbit. At magnitude 13.5, Triton may be visible in larger telescopes. Now for fun with a marathon. The Messier Marathon, the project to see all 110 of the Messier catalog's galaxies, clusters, and nebula, is best done in late March when all 110 can be seen from mid-northern latitudes. However, you can marathon the Messiers any time of the year, but you just will not get all 110. New moon is September 17th, and the weekend, Saturday evening, is September 19th. So what would a Messier Marathon look like on September 19th? Well, the sun is nearly at the equator, headed south and south of Leo. From mid-northern latitudes, the many Virgo galaxies are less than 5 degrees above your western horizon as the sky gets dark. Probably forget those. I would start with M64 and M53 and M3, then head south to Scorpius and go after M80 and M4 and so on before they set. Then north for M81 and M82 and the Big Dipper galaxies. Then back south again to Sagittarius and the southern Milky Way, then head back up into the northern sky. Within 2 hours of when you start, you will probably get your 71st object if you cover everything that's above the horizon. Last month, after 2 hours, we got 87 objects. The drop in numbers this month is because we lose all those Virgo galaxies in the western sky and pick up almost nothing new in the eastern pre-midnight sky. As you near morning, you get the winter Milky Way items, then M44 and M67. If you're lucky, you can get the galaxies M95, 96, 105. The night will likely yield a total of 89 of the 110 objects. This is the least number you're likely to find on an all-night Messier Marathon for the entire year. Mid-September is nothing like late March. You have been listening to Looking Up with Don, podcast episode 36 for September 9th, 2020. I'm Don Markholtz. Once again, the related website for this podcast is donmarkholtz.com. That is spelled DonMachHolz.com. 2 H's. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the sky, introduce Comet Atlas, now visible in our morning sky, and look at more comet discovery stories from the book A Decade of Comets. All that and more. Thank you for listening. See the sky this week. I'll see you next week.